Alright, let's look at the type of forces that could be present on a free body diagram. Now we're going to classify these forces into two categories: contact forces and field forces. You'll want to sketch in your journal a chart similar to this one so that you can add some forces to it in just a minute. So what types of forces are there? Well, the ones to the left, the applied force, normal, tension, friction, and spring forces, are known as contact forces. Simply put, they are caused by something touching or being in contact with the object. The forces on the right, gravity, electrostatic, and magnetic forces, are forces that act at a distance or through an invisible field. We'll call them field forces. They're caused by something pushing or pulling the object without actually touching it, much like how the Earth can pull a ball downward without the Earth actually touching the ball. Well, let's very briefly look at each of these 8 forces. The applied force. When a person directly pushes or pulls an object, we typically call this force the applied force. In this case, the applied force pushes the cart to the right, so we'll use an arrow pointing to the right to show this. The normal force is a very important force as well. It's the support force, a force that often holds an object up. Now, normal means perpendicular, and since the ramp surface is horizontal, it provides a normal force or a perpendicular force pointing straight up. Strings and ropes provide tension forces. Since strings and ropes can pull, but they can't push, they will always point in the direction of the rope itself. Now, when two surfaces are in contact with each other, such as the cart rubbing along the track as shown here, we have friction. This force often, but not always, acts opposite the direction of the object's motion, as it serves to slow the object down. In this case, friction points to the left. Springs can also provide forces as well. In this case, a stretched spring pulls the cart to the right. Unlike ropes, however, springs can push or pull. All right, now let's look at the field forces. The most common one by far is gravity. Gravity is the force that the Earth exerts on the cart. Gravity forces always act on objects, pulling them toward the center of the Earth, always straight down. Well, later on this year, we'll encounter what's called an electrostatic force. Now, let's say that these two carts shown here are both positively charged, for example. Even though they're not in contact with each other, an invisible electric field causes the right cart to be pushed to the right. So we'll draw an arrow pointing to the right and call that the electrostatic force. Now, the same is true for magnetic forces. These carts have magnets in their ends, and the right force, again, feels a force to the right, but this time caused to do two north poles of magnets as opposed to charges. So this is a magnetic force that points to the right. As you'll be using these forces very often over the next weeks, let's make sure that we have these well organized into our journal. We'll even come up with a shorthand notation, shown in parentheses here, that we'll use to label the arrows on our free body diagram. Why don't you hit pause and copy this down into your journal. All right, let's see what you remember. Identify each of these forces as either contact forces or field forces. You can answer these below.